Have you ever wondered how to tackle an exam paper under real test conditions? In this video, I'll solve the entire 2024 June IAL P3 math paper in one take. No cuts, no edits, just as if I were a student sitting the exam myself. What I'll do in each of every question is I'll walk you through my thought process, explain why I make certain choices, and share my approach to time management. And at the end, I'll mark my answers to see how well I did. Okay, let's get started. So the paper will be an hour and 30 minutes long. Let's go. So I would just go ahead and do the first question. Figure 1 shows a sketch of the graph with equation y equals fx. So that looks like a modulus graph here. So we have this equation right here. The point P shown in figure 1 is the vertex of the graph. State the coordinates of P. Well, that is obvious. You can just look at this modulus part here. You can put it to 0, and that will give you x equals 5. And the y coordinates of P here would just be whatever is left outside the modulus function. So that would be 5 and 10. So the answer is 5, 10 here. B, use algebra to solve whatever that is. So we can sort of like plot this part of the inequality briefly first to see how many points it should cut. So as you can see, I would look at the gradient of the 6x part here. So we're going to plot y equals 6x. As you can see, 6x is quite steep compared to the V shape up there. So maybe your line will look something like this. Yeah, because it's steeper, so it should be quite higher up like that. Now, as you can see, we want the solution of this part greater than this part. And that means graphically that we want the part where the V shape is above the red line. So where that is just, well, you see that there is a cut point here to intercept between the red line and the V shape. So the part where V shape is above is going to be the part where, hang on, that's weird. We want the part where V shape is above the line. That is just this part right here to the left of that part. Now, some people think that they have, so some people might think they're going to find two solutions of the intercept first. But as you can see here, as I already drew the red line, it only cuts the V shape at one point. So that means whatever this solution is, we're gonna answer the range to the left of that point. Okay, so we're gonna find a solution here first. So we're gonna take the V shape, the line of the V shape where the gradient is sort of like negative. So we can just make it, so my working would be, let's say, okay, I'll put it here, B. So 2, we're gonna put a negative sign into this. So that's gonna be minus x minus 5 here. Okay, so this is minus times everything inside and plus 10. Because we want to solve for that intercept, I'm going to put it equal to 6x. And I'm just going to solve for this, right? So it's going to be expanding out. So minus 2x plus 10 equals 6x. Yeah. Just let me check because I'm very careful here. So minus x and plus, yeah, that's fine. So we isolate x. So we get x equals 20 over 8, which is 5 over 2. That would be my answer there. So this is 5 over 2. Yeah, because it's the x coordinate of the intersection. So our answer is going to be where this is to the left of the V shape. So I'm just going to go like x is less than 5 over 2 because we want the part where this is greater, right? And that would just be my final answer there. That's it. So for C, well, for A, already answer here. For C, find the point to which P is mapped when the graph with equation y equals fx is transformed to the graph with equation y equals 3fx minus 2. So guys, according to transformation, when you have something inside the brackets here, yeah, this is shifting left or right. If it's a minus, it should be to the right. Minus whatever the number is, it should be a positive number here. If it's a plus, it is shifting to the left. So this is saying shifting to the right by 2 units and multiplying or stretching the y-axis by 3 times, right? So that's just for you to understand quickly there, right? We want to find the point to which P is mapped when it's transformed by that. So P is going to be mapped by what? Because we're going to move to the right by 2 units. So that's going to be, you know, from 5, it's going to be 7. And then we're going to multiply the y because it's stretching here by 3. So that is just 30 there. So the answer is 7 and 30 to the new point P, right? I'll just say P prime maybe. And that's it. Yeah. So the next question, question 2. This is about functions. Well, actually not. It's about algebraic method in P3, right? So we have to split the gx into these terms where we have to do probably long division. All right, so guys, I'm just going to do long division here. So let's do long division. That's the dividend inside the division sign there. And x minus 2 is the divider, right? Let's move the thing a little bit further down because I don't have some space there. Okay, so quickly, we're going to take the first term here, dividing into that. So I get 2x there. Yeah, you can check. And then I would get down here 2x squared, 2x multiply minus 2, I get minus 4x. If you minus the first and the second line, that goes away, the first term. Minus 5x minus 4x would get me a minus x and then plus 8. So again, we're going to divide this into this. So we should get a minus 1, guys. And then we multiply it back. So we have a minus x here and plus 2. You got to be careful with the symbols, the signs there. And again, we minus the 2 lines. We get 6 here because this term, these x's go away anyway. So the remainder is 6. Now, how do we write in terms of this? So this part here would be the quotient of the long division, which is these, right? So the answer to A would be 2x minus 1 as the quotient there, plus C would be the remainder, which is 6. And x minus 2 is already what we have, is the divider. So that would be my answer to A. Okay? Now, B, hence use algebraic integration to show that blah, 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 whatever, where alpha and beta are integers to be found, right? So we're going to integrate gx, guys. That's not hard. Well, we can just write whatever we got here, 2x minus 1 plus 6 over x minus 2. I'm quite thorough with symbols and notation, so there you go. And we're going to integrate split, right? We're going to split these and integrate separately. So the first integration would be 2x, again, using this integration formula, very easy. So when you integrate a polynomial, when n is not minus 1 here in this case, right? Got to be careful. So we get x to the n plus 1 over n plus 1. Yeah, that's pretty straightforward. So we would get 2x squared over 2 there for the first term. Integrating minus 1, we get minus x. Integrating 6 over x minus 2, right? We should get a ln. So that would be 6 ln x minus 2 here. And because there is no coefficient in front of x here, we don't need to do the reverse chain coefficient. And I'll just do a plus c here. But because I spot that, I need to do the substitution. So I need to substitute 4 and 8 right there. Now, I wouldn't like to rely on calculators so much, so I would just simplify everything first. So x squared minus x. And B, we already know that 8 and 4 are both positive, so we don't need the modulus sign there. So I'm just going to go like 6 ln x minus 2 here. All right. And then we're going to substitute 4 and 8 in to get the answer here. So I'm just going to do this, yeah? To me, I'm just going to do maybe differently from other people. So I'm just going to go like 8 squared minus 4 squared. So I'm dealing with one term at a time and do the minus already. Yeah, so I'm done with the x squared term. And then I'm going to do minus for the second term x. So that would just be 8 minus 4 for the minus x here. So I put minus outside the brackets. And then I'm going to go like plus 6. So I put 8 in the x. I get 6 ln 6, right? And then I put 4 in the x. I get 6 ln 2. That's it. Just checking everything if I didn't make any mistake. So 64 minus 16, that would be minus 4. I'm just calculating through, guys. Factorizing 6 out, I get ln 6 minus ln 2 inside the brackets. So that would be ln, using the log property, 6 over 2. Simplifying again without a calculator because I don't like using it. So 44 plus 6 ln 3 there, just simplifying them. And did I get the right form here? Looks like I did. So yeah, I'm just going to double check everything because I'm thorough here. So did I integrate correctly? Yeah, I did, I think. So 6 ln 8 and 4. Did I put the right limits, the right bounds? Did I substitute correctly here? 8 to the 2 minus 4 to the 2. And then I do this part, 8 and 4. 8, we got 6. 4, we got 2 there. This is getting ln 3, 4. This is together minus 20. So I get 44. That should be fine, guys. I think I'm going to pass that one already. So next question, number 3. The variables x and y are connected by the equation that sketch the graph of log 10y against log 10x. Right. Show on your sketch the coordinates of the points of intersection on the axes. So where's the sketch, guy? We need to sketch. Oh, it doesn't say, it doesn't give you any figure. So I guess we got to sketch in our own space, right? So I'm going to do it here, right? That shouldn't be a big deal. All right, so x and y, right, guys? So, right. Okay. Interesting. Okay, so I think we need to simplify this equation first, guys. So, yeah, I think so. Let me double check that. Yeah, okay. So I'm going to take log on both sides. Log 10, which I don't need to write 10. I'm just going to say log y equals, hang on. Let me improve my handwriting a bit. So that's log y equals log of 10 to the 6 over x to the 3, right? And I'm going to zoom in a little more here. So I have log y, which is log base 10 of y. Now, according to the log property, right, we have 10 to the 6 here. And these are dividing in the brackets of the log. We call them the argument. So what time do we have? Just 12 past. Okay. So I can split them into log of 10 to the 6 minus log of x to the 3, right, guys? Okay. And because this is log base 10, so log base 10 of 10 to the 6, that should give you 6 if you put that in the calculator. I just don't have to. So we get 6 there. And then because it needs log base 10 of x, so I'm just going to use log property to bring 3 down there. And here is log x, right? So if we want the plot log y here, that should be a log y, not y. And that should be a log x, right? On the x-axis. So this is just a linear with a negative gradient minus 3. Okay? And the y-intercept is 6. So I'm just going to go 6 here. And minus 3, right? So it should cut on the x-axis at around 2 because the gradient is minus 3. So if you do the math here, 6 going down 6, going to the right by 2, that's the gradient of minus 3. So that would be my line, guys. All right. Here we go. So that's done. That's my part I, basically. I answered them right there. Should be fine. Sketch the coordinates of the points of intersection. Okay, I need to, yeah, I think that's fine. This should do. Okay. Now, what is this figure 2? Figure 2 shows the linear relationship between log base 3 of n and t. Show that n equals ab to the t, where a and b are constants to be found. Well, yeah. So because this is a straight line, it says linear relationship. So we can start by saying things like, because y equals mx plus c, but y in this case is log 3 of n equals m, x is t, and plus c. And then we just start filling in details in this equation. So what is the m? What is the c? M is the gradient, guys. So m here would be rise over run, as you already know. So rise is that, run is that. So sorry, no, rise is that, run is that. Okay, so rise by 4 and run by 2, right? So gradient is basically 2. We got the m already. The y-intercept is simpler than that. It's already given us that. Okay, so that's 4. So log 3 of n is equal to 2t plus 4. And now we want to derive into an exponential form. So you got to do something with the log here using log properties. All right. What do we need to do? Okay. I know that so when you see a log base 3 here, you can sort of like pull 3 to the other side to be the base of the index. So let me show you how. So I'm just going to do n equals 3 to the everything on the right side. Just like that, yeah? There you go. Okay, but how do I get the a here? Well, guys, according to a to the m plus n equals a to the m times a to the n, we can split this into 2 split terms. And people don't recognize that. People don't recognize that very often. They usually missing this. They forgot, because what they normally recognize is the other way around. So they recognize from the right hand to the left hand, right? That's the same property, okay? So this is important. So I'm just going to simplify accordingly there. So I get 3 to the 2t 3 to the 2t times 3 to the 4. So it is already obvious that 3 to the 4 will be our a. So I get n equals 3 to the 4 happens to be 81. Yeah, I just know that. And 81, 3 to the 2t. So that will be my answer, guy. Oh, no, not yet. See, it's a b and there is no number in front of 2. So I almost make a mistake there. So this is 9 to the t. So we use this property here, a to the m brackets to the n. We get a to the m times n. Because I'm doing from right to left here, I can split the 2. To power just the 3, I get 9, and that would be my final answer for that question. I think I'm done here. I'm just going to go. We're almost halfway, guys. I only spent like 17 minutes. Yeah, so far so good. Number 4, trick. Write fx in the form of these. So yeah, so occurs to me like we're going to do double angle there, right? Because we have a sine and a cos multiplied together. And again, this is a double angle for the cos. So here we go. We know that, yeah, I'm just going to write the formula here. We know that 2 sine x cos x equals sine of 2x, yes? Okay. So, I mean, it depends on, how you look at things in this question. I mean, we can look at it like, okay, because we have 2 sine cos equals sine 2x, so I can multiply 4 on both sides to get 8 sine x cos x. And that will give me the right side, which is 4 sine 2x, yeah? And that term will be 4 sine 2x easily, right? So I'm just going to answer here. So this will be 4 sine 2x. And then plus, what about this? Again, we also know that cos 2x is 2 cos squared x minus 1. You have to know this formula, guys, if you take this exam. You probably should remember this. So because we want cos 2x squared, I can isolate cos 2x squared there, or I can make this term the same as this term and isolate it later. Well, let me show you the latter method. So if I multiply by 2 on every term, so I get 2 cos 2x equals 4 cos squared x minus 2, right? That's just multiplying out by 2. And then I isolate cos 2x squared just to get that term. And then we get 2 cos 2x plus 2, right? So I can substitute this into this, yeah? So those would be my working altogether, right? So I probably need to move here to get the marks, right? Otherwise, I won't have any working. Yeah, anyway. So I'm just putting it down here, maybe. Here we go. I hope the examiner won't mind because it's going to be myself who marks this paper. But I'm going to show you how I mark the paper as well, just for transparency there. Let me just arrange things around first. I'm wasting time here. Hang on. Sorry. Okay, let me just delete this. Yeah. So I already got the first part, which is the sine part. So I'm going to use, what was it again? 4 sine 2x, right? Yeah, for the first part. So 4 sine 2x. And then this part, I got 4 cos squared x to be this part here. So I substitute it in on the right side there. And then I got to keep this minus 3, guys, because we haven't derived that term to be anything else. Okay. So that's it. Simplifying it would give you this kind of form, which is 4 sine 2x plus 2 cos 2x minus 1. Answer. Okay, we got the form already. Use the answer to part A to write fx in terms of that. So that is called, guys, harmonic function. That's just a jargon, really. Okay. Use the answer. Yeah, right. Okay, I've read that. So yeah, the quickest way to do the harmonic function here, of course, is we can find the R already first. I don't know why my camera does that. Hang on, okay, here we go. I'm back. Okay, so we're gonna just take these two parts and make it harmonic. The quickest way I would approach this is to maybe find R first, and that quickly can do the Pythagoras between the 4 and the 2 there. So that's 16 plus 4, I get root 20. Or if I want to simplify it, it's just 2 root 5, right? That's fine. That's my R. Now, in order to find the alpha, I need to maybe take this form. So I have R sine 2 theta, 2x, sorry, plus alpha. This can be then split into R sine, So the sine, we can use the sine, additional formula of the sine A plus B. So that would be sine A cos B plus, with the R here multiplied in front, R cos A sine B, right? And A being the 2x and B being the alpha. Now, we can just compare the term here, right? So we compare the term because we want this to become something like this, which is actually on the right side. But because we already have something similar here, so we're going to compare 2x here, sorry, sine 2x here with the sine 2x here. That means the leftover here, which is the R cos alpha, is going to have to be mapped to 4, right? That's how we do it. So we can say sine, R cos alpha is going to be equal to 4. And that is just the term that we need to do because we already got R. So believe it or not, this is what you need to do. So we can do cos alpha equals 4 over the R value you already got, which is that. And this time I need a calculator. So because I have to do alpha equals R cos. So 2 cancel a bit there. I get 2 over root 5 here. So I'm going to do, so let's check. We answer in radian in quadrant 1. So I'm going to do R cos here. Hang on, R cos. Fraction 2 over root 5. And that gives me quite a long decimal there. It's 0.4636 ... That's it. Okay. Or I can round it to 4 significant figures. Just that's it. But it says 3 significant figures. Okay. We already got the exact value of R, but alpha should be in 3 significant figures, so that should be 464. That's my alpha. Now, C, hence or otherwise, state the maximum value of fx. Well, this is easy peasy, guys. Wait, hang on. Use answer to part A to write fx. I haven't done this. I gotta be careful because I need to write the whole fx in totality. Okay, so fx equals, I almost got it wrong, guys. So this part becomes that, and that only becomes this, right? Yeah, I forgot the plus c there. So I'm gonna have to write, therefore, fx is equal to, what is that? R is 2 root 5, and then we have a sign and a 2x and a plus alpha. So that's just the first part, and plus c, which is what we already got from the first question, which is this guy. All right, so that is just -1. This is the actual answer. Phew, almost. Now the next bit, hence or otherwise, state the maximum. Okay, guys, these kind of questions trick people time to time and again, right? So when we consider the maximum value of a partially harmonic function like this, you got to think about the term that can vary. So only this term can vary. And you know about the nature of the sine term. The maximum is only 1. This whole thing, you got to look at just the sine, and whatever the angle in the argument, we can ignore that because the maximum it can be is only 1. So if we want the maximum, which we do here, we can just make this whole thing become 1. So I can say maximum value would be 2 root 5 times 1, that whole thing, and -1. So that would be 2 root 5 minus 1. Okay. I can just keep the answer exact like this because I would like to. And then this is the first part. And then the second part, find the second smallest positive value. Second smallest, that can be tricky, guys. Smallest positive value of x at which a maximum occurs. Well, the condition, this is where most of the students I teach sort of like got confused because they would like to just equate the whole thing, equate the maximum value they just got to the whole equation, which is a bit of a waste of time because the condition you make it maximum is only from this term. So you can just start by saying, okay, I know that the maximum occurs at this, right? Why would you just go say the whole function? You can just start from that and you can say that that is equal to 1. That is a lot simpler, guys, right? But we got to be careful because we need to solve for x, and x should be a positive value. So that's x greater than 0. If x is greater than 0, but according to the way we solve trigonometric equation, we gotta derive for the range first. It is better to look at the actual range that we are solving here for the angle. So because x needs to be positive, so x greater than 0, that means if I derive the argument part here, I would get 2x plus 0.464 greater than, well, you can just multiply 2 both sides, but that doesn't change 0 here. So it's still 2x greater than 0. But then when you add this bit, you're going to get that on the right bit too. All right. See if you are actually happy with this, but I'm just going to go and say that this will be greater than 0.464 as the range of my angle here. Okay. So we're going to do arcsine of 1 first, right? To get something I call the basic angle. Basic B angle A. So I want to find the basic angle because I'm going to use what's called a cast diagram, right? So a cast diagram. So arcsine of 1, I happen to know that it is pi over 2. Well, we can go minus. No, we can't go minus. Yeah, so pi over 2 is probably the best shot there. So pi over 2 is here, right? And we don't seem to have any other alternative. But we got to be careful because we need to do the second. I still remember the second smallest. So how about we go for another one? And that would mean that we need to go like that. Just another period. So this is one period adding on top of pi over 2, right? It's like one cycle, one revolution. So that's going to be 2 pi plus pi over 2. That would just be 5 pi over 2 by my calculation. Okay, yeah, let me check that. Yeah, no, that's 2 pi plus 1 over 2. Yeah, it should be, yeah, it's 2.5, right, basically. All right, I'm just being thorough. Now, that seems to be the second already. We don't need to go for the third. Well, that means if I want to solve for x, I need to equate 2x plus 0.464 equals 5 pi over 2 because I'm taking this one, right? So x is just, I'm going to use a calculator here because I want to be accurate. And the answer is going to be 3 significant figures. Let's see. Yeah. I think I'm going to, you know what, guys? I don't feel secure. So I'm going to take this as my alpha. So that's arc cos 2 over root 5. Because I wouldn't be using this one. Okay, it's the same amount of significant figure as the final answer. So let's write it down first. X is going to be equal to 5 pi over 2 minus this is the alpha, which is the arc cos of 2 over root 5 in radians, of course, and all divided by 2, right? So I'm just going to go put the whole thing into my calculator. So I do a fraction first and then a fraction again. So 5 pi over 2 here. And then on top, I still have minus cos fraction 2 over root 5. There we go. So that should be done on the top part. I put a bracket there and then divide by 2. The answer that I got from my super calculator is 3.6. Oh, that's 3.70, right, guys? Because we need, we need 3 sig figs. Yeah. Answer, just one answer. Yeah. So 3.70 would be my answer for the X. Now I'm done with that. Alrighty. Let's go next. Okay, this should be quick. We want to find the inverse of F22. Yeah, it's like just substituting 22 in, but we should find the inverse first, I think. All right. So we find the inverse. So inverse of Fx. Well, yeah, most people just do like this. So they put, this is going to be the y, right? This left-hand side is y. So we can say x there and then equals 2 plus 5 ln y. And then you make y the subject or isolate the y depending on where you are. So I'm just going to go like x minus 2 equals 5 ln y. And x minus 2 over 5 equals ln y. So I'm just switching the side here. Ln y equals, again, guys, I just showed you earlier that we can just, because ln is basically log base e. So we're going to have e becoming the base to the power of the whole term on the right side, on this side, I mean. All right. So that is our F inverse, which is that function there. Now we want F inverse of 22. So that would just be e to the 22 minus 2 over 5. So that would be e to the 4 because 20 over 5 is 4. Yeah, yeah. There you go. All right. So that is my answer, e to the 4 as an exact value. Use differentiation to prove that g is an increasing function. G is an increasing function. Use differentiation. Okay, basically it asks you to differentiate gx. So g dash x, that's the derivative of gx. Well, guys, what do you think? I think we should use quotient rule, right? So bottom differentiate top, which is differentiate this part, I get 6 minus top part, differentiate bottom, I get 2, right? And then all divided by the bottom part squared. Yeah, that's the quotient rule. Now, why is it an increasing function? Well, increasing function means that the derivative should be always greater than 0. And we're going to have to reason why that is. So, right? So let's simplify a bit. The top part, I get 12x minus 6. This part, I get 12x also. Subtract it here. And this is minus 4 minus minus, I get a plus 4, right? So divided by the same thing. So as you can see, this can cancel. I get a minus 2 over 2x. Wait, this should be a plus, right? I forgot. I made a mistake. Sorry. So 2x plus 1, and that should also be a plus. Yeah. Now, guys, to reason this, why it is increasing, why it is an increasing function, because we say because, I forgot a square here, because 2x plus 1 squared is always, or we can say, yeah, we can say always positive because it cannot be 0. So 2 over 2x plus 1 must also be positive. Therefore, g dash x is greater than 0, increasing function. So gx is an increasing function. There, right? Okay, so that's my B. That's long. Find G inverse. All right, so G inverse, again, I'm just gonna do it right here, maybe, just to not having to go up or down all the time. So this is my C. Okay, G inverse, yeah. There is a trick to this, but because we need to get the method mark, so I'm not gonna go too fast. So again, I'm just gonna make Gx as our Y, which we need to swap to X, and whatever the X is, whatever the X, wherever the X is, we're gonna need to change to Y. Okay, here we go. So multiplying out to the other side, so this bottom term multiplying to the other side, I get x to y plus 1 equals 6y minus 2. Multiplying out, I get 2xy plus x equals 6y minus 2. Because I need to isolate y, so I need to collect the term y. Let's make the term y on the left side and whatever is not y to be on the right side. So I get minus x minus 2 there, just moving x to the other side. So y here, isolated out, factorized out, I get 2x minus 6 there. Just going to keep writing first. So y equals minus, I can pull the minus out here from the x and the 2. So I get x plus 2 in. And then I can just do that. So the minus outside the brackets means that it has to be going into the two terms if you want to simplify it back, right? So that's just it. So that would be my G inverse. Okay, so I'm just going to say, therefore, my G inverse of X is going to be that answer. Let's double check, right? Because I might make a mistake there. So blah, blah, blah. Let's, yeah, 6y move there, x move there, become a minus. And then pulling y out, I get 2x minus 6. Moving down there, yeah, everything is good. Find the range of fg. Now, this part is a bit tricky. But here's how I do it, guys. So I'm just going to put it here first. So we got to find the range. So fg is basically f of gx, right? The way I would do it is to find the range of gx first, because the range of gx is the possibility of where you can put a value inside the function f. So the range of gx we need to get from this guy, right? Okay, so this is going to be a bit tricky. So the range of gx, we got to look at the nature of the reciprocal function itself. So you must already have learned that in this case, x cannot be a minus 1/2, right? Because the bottom part cannot be 0, but that is already covered by this specified domain. So we don't need to worry about this, right? Okay. But if we want to find the range of gx, we got to deploy or apply this x value, because it is the lower bound of the x, to try see what's going to happen to the y. So I'm just going to substitute that when x equals 1/3, g of 1/3 would be 1/3. Yeah, I'm just doing mental math here. So that would be 0 on top, right? Because 1/3 times 6 is 2. So it's just 0 there. And as the nature of the reciprocal function, you cannot. So imagine, guys, if you look at the gx here, and then you imagine if x tends to a very, very, very large number. Let's say 1,000,000. So it's 10 to the 6 minus 2 over 2 times 10 to the 6 plus 1. You can see that the minus 2 here and the plus 1 here become negligible, right? So we can cancel it out. We just want to find here what the y value tends to be. So we cancel that out because we want to see like the bigger picture here. And then we can also cancel this out because it's the same value, x. So we can see that the y value would tend to 6/2, which is 3. It can only get closer and closer to 3, but cannot quite reach 3. It's got to keep going forever. So that means we have already got ourselves the upper bound, or the upper limit, whatever you want to call that, the upper limit of the gx. So that means the range of gx, yeah, I write like that. So I write here range of g would be y less than 3 and 0 here. Because if I sub x as 1/3 into the gx, I get 0. And if I look at the tendency of the function here, I get y approaching 3. So the only way it makes sense is to pull two things together as the range of g like that. Now, guys, back to the composite function here, f of g. Because the inside here, like the inner function here of f, like this is actually the domain part of f. But that happens to be the range of g. So this is effectively, we are taking the domain of f as the range of g. If you don't follow this, maybe, wind back and just listen again. Because whatever you put in the x here would become the domain of f. But the domain of f initially was given to be x greater than 2. But now because you are compositing the function, you are changing the domain to 0 to 3 instead. So this is our new domain, right? So instead, we're not going to use that. We're going to use 0, x, and 3 like this, right? That's our new domain. So we got to consider the range of the composite function from this new domain, right? So the range of fg, okay? So we can just try put 0 in here, but that cannot be, right? So if we put 0 here, it wouldn't be valid. Of course not. So if we try put 3 in the x here, we would get 2. One of them would be 2 plus 5 ln 3. But what are we going to do with the 0? Okay, guys, if we think of the graph of ln x, right? This is ln x. So if x is approaching 0, ln x would be down to the negative infinity. It would be very, very large negative infinity. As you go towards 0 here, you're going to keep going down. And that is a very large negative value. And if we put this ln x to be a very large negative value, this whole thing will be a very large negative value. So we don't quite have the lower bound here because it can go to the negative part forever. And that means the best way we want to put the range of fg here would be just less than this value. So that would be the answer there. Just y less than 2 plus 5 ln 3. And that's it. That's my answer to D, guys. Let's skip to question 6. Now I'm at 45 minutes. Still looking good to me, I think. Okay, we got this figure. And line L shown in figure 3 is normal. Okay, normal to the curve at point P, which is 8, 5 here. Okay, use calculus to show that an equation of L is that. Okay, guys, so it says normal, right? So we need to find the gradient. Yeah, so the gradient comes from dy by dx when we want to find the gradient of this equation. So I'm just going to differentiate that. But first, let me put that into an easier look, which is that to the power of 1 over 2. So when I differentiate, I bring the power down for the first step. This is a polynomial integration, differentiation. And then inside, I keep the same at the first step. And then I subtract the power by 1, so I get a minus 1 over 2 there. And then I do the chain rule. I must multiply by 4, so that would be simplifying to be 2 over negative. Okay, so that would be yeah, because I prefer a positive power here, so I bring everything down as a square root. So that would be my differentiation. Okay, and then we're gonna have to show that the gradient at the normal, so dy by dx at x equals 8, right? Because the normal intersects at 8. It's going to be equal to, substituting 8 into the derivative form here, we get a square root of 4 times 8 minus 7. And that would be 2 over square root of 4 times 8 is 32. 32 minus 7 is 25, right? Square root. So that would be 2 over 5. Don't need a calculator for that. Now, 2 over 5, again, we're going to use the formula here. So y minus y1 equals mx minus x1. That's the linear equation formula, if you want to form one. So, I forgot. This is the gradient of the tangent. So the gradient of the normal would be, just putting a minus sign and swapping the top and the bottom part, just to make it quickly. And then we can do now inserting everything in. So we're going to take the same point here, 8 and 5. So y is 5 there, equals the gradient of the normal. And then x minus, x is 8. Okay. So if I multiply everything out by, what should I multiply? Multiply by 2, right? So I get 2y on the left and minus 10. And that would just be minus 5x expanding out already, and then plus 40 expanding in. So moving everything on the left side, that looks good. I get 5x plus 2y minus 50. I got it right. Yeah, that's as required. And the region R, next one, the region R shown, shaded in figure 3, is bounded by the curve, the x-axis, and the line L. We're going to use the algebraic integration to find the exact area. So guys, my intuition says that I should split this into 2 parts. That's not very straight. Yeah. Where the x value of this is 8. So we are lacking the information about these 2 points. Okay. So this point will be the x-intercept of the straight line we just found. Right? The straight line we just found. So the x-intercept, we can just put the y to 0. when you put y to 0, you get, that goes to 0. So you get 5x equals 50. So x equals 10. So that would be 10, yeah? Okay, that would be 10. So let me put it there. 5x plus 0 minus 50 equals 0. So 5x equals 50. I shouldn't write that too long. X equals 10. Okay, that's just part of the working there. Okay. And then this point here, we need to make the curve here equal 0 to find the x-intercept. So that's square root 4x minus 7 equals 0. How are we going to solve that? Let's square that both sides and then makes x the subject. So I get that. So that should be the x value on that, right? Quickly. And so we're going to integrate into two parts, the curve part from 7 over 4 to 8. So we do integral 7 over 4 to 8 of that integral. I'm just changing it to an index form again because that's easier to look at. And plus another integral between 8 to 10. But, well, you don't need to do integral because we know that this is a straight line that is a right angle triangle. So we can do half times base times height. So that is a base of 2, the height of the y value here, which is 5. Okay, so we can do half times base of 2 times the height of 5, I think. Yeah, just to make sure. Okay, just do the job here. So we get, we integrate first. So I'm just going to integrate already. So this is, again, the polynomial. So we just do that to the power of that adds 1. We get 3 over 2. Divided by 3 over 2 here, which I would prefer to write as 2 over 3 down here, because just flipping the fractions there. And don't forget, we also do have a reverse chain rule. So you need to divide by 4 in extra there. So it would be 4 times 3 down here. But because I can cancel that, guys, so everything here would simplify to 6 here. If you're not happy with this, just go back and check it out again. So that's just the integration of the first term. The bounds is 7 over 4 on the bottom here and 8 for the upper bound. And this one here, just canceling, I get plus 5 right there. Okay, so yeah, so this is just substituting, right? So let me just do a mental math there. 32 minus 7 is 25 again. So 25 to the power of 3 over 2 over 6 minus, this is horrible. Oh, not that horrible. 7 over 4 times 4 is 7. But then that vanishes to 0 and then plus 5. Okay. I happens to know that, of course, 25 so that is, let me do mental math. So I would do 25 to the power of half first and then to the power of 3, which is the same as that, right? So I would get 5 to the 3, 125 over 6 plus 5. That would just be 155 doing the fraction there over 6. That would also be my answer, exact value, right? Is that? Yeah, so that's it. I'm just going to go ahead and go to the next bit, question 6. We got about 40 minutes left. Sorry, question 7, right? Yeah, okay. Given that this is this, okay, we're going to show, okay, guys, it looks like we got to show that into this. So you see the 45 and the 60. Well, the final form doesn't show you those angles. That means we got to get rid of those angles somehow. That means the best bet you have is to use the additional formulae. So on the left side, we have, let me put A there. Additional formula for sine is sine x cos 45 plus root 2 here. I'm going to keep it here. Cos x sine 45, right? Yeah. I don't know why I write too big here. Hang on. Let me just, okay. There we go. That would equal to the additional formula for the cos A plus B. This is cos A minus B instead, so gotta be careful. So for the cos For the minus in the cos, we do a cos plus sine. So that would be a cos x cos 60 degrees plus, right? Because the sign is opposite. Sine x sine 60. Aha. Now, I happen to know the basic angles for the trick, so I'm just going to go simplify as much as I can. So cos 45 is 1 over root 2 here. So that would cancel. I get sine x only here. Sine 45 is also 1 over root 2, so that's just cos x canceling out. Cos 60 is 1 over 2, so I get 1 over 2 cos x here. Sine 60 is root 3 over 2. I get through 3 over 2 sine x here. Now, it seems like we need to capture the tan x. And yeah, we can just simplify. So I can just move cos here and move sine x there, right? So I get on the left side, 1 minus a half. So I still get a half cos here on the left. And moving sine x to the other side, I get that. And then factorize the sine out. Yeah. So if you subtract sine x from this term, you get that. And yeah, it seems like I need to make tan. So I'm going to move cos here down to the other side. So that makes me get a tan over here. And I'm going to move this whole thing here to this side. That's going to be a bit intriguing. So this side here, I'm going to get 1 over 2 times that whole lot on the right. Okay. So I can decorate a little bit here. I get 1 over. So 2 multiplying in, I get root 3. 2 multiplying in, I get minus 2 there. Of course, guys, we should do the conjugate thing, the rationalizing. Yeah, sorry. Okay. So I put brackets here to be safe. So the top part is root 3 plus 2. The bottom part is just, 1, basically. You can try that in a calculator, but of course, well, actually minus 1 because I get 3 minus 4. So that would be minus 3 minus 2. Is that right? Yes. Okay. So B, hence or otherwise solve. So looking at the form here, we got to match the form. It looks like x plus 45 would become 2 theta. And yeah, so hang on. So if I put x plus 45 here, minus 105, that would give me back to that. Yeah, so in this case, we can see that x plus 45 would have to be 2 theta. Okay. So that means we can just solve, so x plus 45 is 2 theta. That means 1x is 2 theta minus 45, right? Follow? Just moving that. So yeah, that means if we can only solve for this, whatever the answer is, we can substitute it in here and find theta. All right, that would be my approach there. Okay. Now, but to solve for x, we got to be careful because we have the range of theta there. Okay, so we want to solve tan x equals minus root 3 minus root 2, is it? Yeah. Oh, no, hang on. Wait, how can I get this? I spot my mistake. Good that I fix it in time. Right. That's so weird, right? Yeah. Okay, so we're going to solve this, yeah? But the domain, right? The domain of this is x, which is 2 theta minus 45. So we got to modify the domain first. The original domain given by the equation, by the question, is theta in the range of 0 to 180, not including 180. If we multiply by 2 there, we're going to get that to 0, but on the other side, 360. If we minus 45, this is going to be minus 45, 2 theta minus 45, but then less than 315 because I'm just subtracting from that. This will be the range that we are working on, right? And again, I'm just going to find the basic angle to work on the cast diagram. So I'm doing arctan of these. And I need a calculator again, guys. So arctan square root 3. Move a bit, minus 2 there. No, minus root 3. Okay. And then, so yeah, so this is, I'm getting this angle to be minus 1.308997 then. I'm just going to stop there. But then this is not basic. The basic angle would be a positive value, right? So whenever I get a negative, I should make it positive because I didn't change this to a positive angle. The basic angle should be in quadrant 1. Now, because the tan value here is a negative value, so instead we're going to go for these two, which is this one here and this one here. So this is when we choose the second quadrant and the fourth quadrant where tan is negative. But the basic angle comes into play as shown here. So this is going to be 1.3 blah, blah, blah. And this angle is going to be 1.3 blah, blah, blah. And the way we measure the angle to get the x here, to get the x right, we got to go in the range. So can we go this? Depending on, well, if we are allowed. Oh, no. I shouldn't have. Hang on. I'm going to change it to degrees. Actually, guys, that is just minus 75. I'm almost wrong. Okay, just the wrong unit, I mean. Okay, that's just 75. Happens to be a very good number there. Okay, so I'm going to go 75 here, only the second quadrant and the fourth quadrant. So I'm not allowed to go minus 75 clockwise here because this is out of the range. So I'm going to go the first one here being 180 minus 75. So that would be 105, right? That's the first one. Well, how far can I go? I got to keep going. So from the second one to this, sorry, from that first answer to the second one, we can add 180. So adding 180 to that, you would get 285, right? That's the next one. Yeah. And then if you keep going, adding another 180 in to see if you can get to the other one, you are going over 315. I'm just added there, right? Just doing column adding, basically. Okay, so these are just the two answers for x. And then we could make it to theta minus 45 because that would just be our value here, right? X plus 45 is 2 theta from our earlier deduction there, right? So that means that would be equal to 105 and 285. That means theta is going to be 105 plus 45 is 150. 150 divided by 2 is 75. And 185 plus 45, that's going to be 330. Divide by 2 would give me 165. Yeah, I'm happy with that. So I'm going to answer that. I don't like using a calculator, guy. Okay. All right. So I think I am done here. Yeah. Number 8, we got about 28 minutes. Number 8, still good, I think. Find the value of D, giving your answer 2 decimal places. The answer value of D. Okay, what is D? D is the x-intercept of that curve, right? So I'm going to read the question carefully here. You can do so too. Okay, so the value of D, we can just equate that to 0, right? Because that is where it hits the ground again. Okay, so part A, I'm just going to make that equation. What's that? 1.5x minus 0.5 x e to the power of 0.02x equals 0. Yeah, everything is fine. Let's see if I'm copying everything right here. Okay, solving that. Yeah, first off, we can see that if we put x equals 0, that's one of the answer. But that's trivial because we already know that. That's already in the graph. We want the other one. But we can cancel the x out first, right? So if you rearrange, I'm going to make the exponential term to the right, and I get that, yeah? I'm going to cancel 0.5 and 1.5. So that becomes 3. And then again, the same trick, I'm going to move e to the other side to be ln, because e and ln are inverse functions to each other. And then I can bring the power down there. That's just the trick, guys. So my x here would be 1 divided by 0.02 ln 3, which is just 2 over 100. That would be 50 by my calculation. So x equals 50 ln 3, right? So do we want to get exact? Giving your answer to 2 decimal places. Okay, I'm just going to put that into 50 ln 3. 2 decimal places as required. Okay, that's A. Show that the maximum value of h occurs when that. So maximum value, guys, is that of h. So we gotta differentiate this, right? And find the turning point. So differentiate dh by dx. It's going to be equal to differentiating this, which I already wrote here. So focus on this line, guys. I'm just going to differentiate the left part here, which is h. So differentiating the first part, I get 1.5. Differentiating the second part right here would require a product rule because we have a 0.5. Yeah, so I'm just going to look at this part and I'm extracting 0.5 out. It's like I don't care about it. And I'm just going to do a product rule for these two. So u dv, so dv, d of that, differentiate that, I get 0.02 e to the same thing again, plus v du. So I do du here is 1, so I don't write, and duv, so it's just the same thing there. All right, so that's just the product rule of the second part here, and I'm done with that. So wrapping this up, you can yeah, this is a multiplier, sorry. I normally do a dot there, just not to be confused with the decimal. Yeah, so let me just decorate that a little bit. I can make 0.5 e to the 0.02x here. And then in brackets, I can do 0.02x plus 1. Nicely. And then we want to equate this to 0, right? Because we want to find the turning point. We make it 0. And we want to show that it occurs at that. You see that x are on both sides, so I need to be careful rearranging that. Okay, so what do I do? Okay, seems like I have the long part there. Okay, so I'm gonna move, I'm gonna just isolate 1.5 here and move everything on the other side, right? So that's gonna be 1.5 is basically, 0.5 is basically 1 over 2, right? And then everything. And then that thing. The brackets. Okay. So 2 multiplying out, I get 3 there. I'm just going to delete this because I'm too lazy to write again. 3, okay. And okay, it seems like I need to move this down first before I taking ln. So I'm just going to do 3 divided by 0.02x plus 1 equals e to the 0.02x. And last step would be doing the ln, right? Okay, yeah. So yeah, but before that, I can, do the trick here. I can factorize, because if you look at the brackets here, it only has an x. So that implies that I should take this little factor out, right? Well, I can do that by just taking it out and compensate back. So what do I need to compensate for 1 in order to be multiplied with 0.02 and get 1? So that is just, I think, a 50, right? So that is where 50 comes from, as you can see. Yeah. And if you note that, that is actually 0.02 is actually 1 over 50. So if this is 1 over 50, right, you can see that 50 will be multiplied to 3. Yeah. So 50 multiplied 3, I get 150 here. If you're not happy, you can go back. But this is just multiplying the sorry, simplifying the algebra here before doing anything further. And then I can do the same trick, moving it as a ln here. So ln 150 on top divided by x over 50 at the bottom equals just taking everything down there. That's not exactly the same yet because again, 0.02 is equal to 1 over 50. So that is 1 over 50 there. I move 50, multiply the other side, which I'm going to switch to this side. So 50 ln 150 divided by x plus 50 there would be equal to just my x. And that is just as required. Okay. And then I'm going to use iterative formula, that finding the value of x2. And then we're going to repeat later. So we're going to just put an answer to the first root first. That's just adds, which is 30. And I'm going to put equal. That's already my answer. And then I'm going to do 50 times ln, where's ln, of a fraction, 150 over answer, don't forget, plus 50. Okay, so that is the first iteration that would give me already, but I need to write, somehow I need to write the substitution there. So I'm just gonna do that. So x2 is gonna be equal to 50. I'm just looking at my calculator here, guys. 150 here over substitution was 30, right? Yeah. And that would give me 2 decimal places, which is 31.43. And then we're going to repeat the iteration until we find the horizontal distance traveled by the golf ball before it reaches the maximum height. To answer, yeah. Okay, so we're going to keep pressing answer until the 2 decimal places are kind of like converged. Converged mean doesn't move at all. So as you can see, it is getting to through 30.88. So I'm going to stop there. So this is 30. My repeated iteration says that I should get that as my answer. Done. Okay, next question, number 9. We have about 19 minutes, guys. And we are done. So this is the last question, basically. So the curve show figure 5 has equation that point P, blah, blah, verify that K equals 2. So, okay. So what do we do here? Okay, so the Y value is given to be pi over 3. So to verify that, we just need to substitute Y as being pi over 3. So that's 4 sine squared of pi over 3 minus 1. Sine of pi over 3 is sine 60 degrees. So that is root 3 over 2. If we square that, we get 3 over 4. We multiply by 4, we get 3. 3 minus 1 is 2 without a calculator. So that is just K equals 2. Yes. B, I do it down here. Find dx over dy. Well, just differentiating x respect to y. So differentiating that, we need to do the chain rule for the sine squared. So that would be 4. The chain rule says I bring 2 down and then keep the sine, subtract the power by 1. But I need to do the chain rule. So differentiating the chain in this case, which is the sine function, I get a cos y minus 1 goes away. So that is simply 8 sine y cos y, right? In terms of y, so that's fine. I can also do a double angle, but I don't need to. I can just keep it like that, right? Okay. Yeah, so that's dy by dx, done. The second one, hence show that dy by dx is that. So, okay. So dy by dx, we're going to flip that whole thing and just rewrite that. Okay. So we're going to show that it's a square root there. That seems to me like we need to get rid of the trig functions by using what we have here, right? So what we have there, well, if you play around with this, you will know that if you isolate the sine y, you're going to get x moving minus 1 to the side to be plus 1. then divide by 4, then a square root. So that is the sine y, just the sine y, okay? So here I can say equals 1 over 8. So the sine y is square root of x plus 1 over 4. And then how do we do the cos y? All right. Because we know that sine squared y is 1 minus cos squared y, right? So if we substitute that before we square root, yeah, so if we only do x plus 1 over 4 here, we get sine squared y, right? Which we can change to 1 minus cos squared y, all right? And then if we isolate the cos here, we would get just 1 minus x plus 1 over 4. Okay, so let me write that down for the working. Cos squared y equals 1 minus x plus 1 over 4 equals, so if we do the fraction 4 minus, yeah, so it's going to be 4 minus 1 becomes 3 and minus x over 4. Just doing the math there, guys. And then if we want cos y, then I'll just do, you know, square root of all that. So we can just put that in because we need a cos y there. Seems like we get everything into places. Okay. Now, we can take the 4 into two parts here out because basically the 4 there is just square of 2. So you can take 2 out. So I would get 1 over taking 2 out to be the denominator of the denominator, right? So here is over 2 for the 8, and the square root would be kept the same. So that should leave us to, I don't get number 2 there. What did I do wrong, guys? Let's find out. Must have done something wrong there. I took the 2 out. I get 4. Okay, hang on. Let me check. If I do the sign right, did I? So x plus 1 over 4 square root sign. Yeah. Or did I do dy by dx wrong? So 4 sine. Yeah, I don't think I did it wrong. 8. This is 8 sine and cos. If you do 1 over, you get that. So that's 8. That's 8 sine dy by dx. I'm running out of time. Hang on. So I don't change the h. I just keep it there. Okay, I'm just gonna update my answer here first. That's the closest I can get to. All right. And then I'm just gonna maybe do the next part first, see if it works. Yeah, you know what? I'm just gonna take this, right? Let's figure that out later. The normal to the curve at P cuts the x-axis at point N. Yeah, normal to the curve at P cut the x-axis, so that's gonna be that kind of line at point N. And then find the exact area of the OPN. So OPN is that. We already know the height of the triangle, right? This is a triangle. So we need to know ON and just do half base height. So we need to find the line first. And that means we need to substitute, do dy by dx, where x equals that point K right there, x equals 2. To this derivative that we didn't quite get, right? So I'm just going to do 1 over 2 of 2 plus 1 square root in there, and also that part, 3 minus 1. Sorry, 2. Okay, so this turns to be 1 over 2 root 3, yeah? So that would be the gradient of the tangent, not the normal. So the normal, m normal, would be doing the minus and flipping it up. That's it. Okay. And then we need to find the linear equation. So I do y minus y1 equals the gradient, and then x minus x1. Now we can take things a bit faster here because we already know that n would have to be some x value and y 0, right? Because we want to find x. So I'm just going to take that as the x we want to find. And x1 would just be taken as one of the point here, which is the k again. Okay, that's the gradient. y1 is the same value from the same point. Sorry, the value from the same point is pi over 3. And then the y here is 0 because n at n y 0. We solve for x here already. We get the answer. All right. So that would be 2. Oh, okay. So this is minus pi over 3. If you divide that, the negative sign cancel. I'm going to get 1 over 2 root 3 down here. And then to make x the subject, I add 2. So I get x on the right side. Just doing it faster here because I'm running out of time. I got 10 minutes. So this is pi over 6 root 3 plus 2 equals x. That would just be my n. Do we need to answer exact? Oh, we need to give it in this form, so no problem. This is n, so this length is already that n value, the x value of n. So we do the area of the triangle is half times base, which is just the x coordinate of n, which is that whole lot. And then times the height, which is pi over 3 again from this diagram. Yeah. So multiplying all out. So we get pi over 12 root 3 plus 1 inside and multiply another time again by that. So we get pi squared multiplying pi over 3 inside. And this is 36 root 3 and plus pi over 3. See if I get it right. A and B are constant. I'm just going to risk with that because that seems to be the closest I can get to unless I make any mistakes. Yeah. So that is the area of the triangle, guys. Now let's hunt down the mistake I missed. I didn't quite find here. So again, I'm just going to look at this working for the cost and everything. Oh, okay. I see now. The number 4 here, there should be 2 of them. How stupid I was, right? Okay, I didn't see that. So this is 2 times 2 because I take 2 of them out. So I only get 2 here. Aha, I got it. Yes. Now, guys, because we have 8 minutes left, I'm just going to spend some time to just go through and double check everything. If I answer like the significant figures and stuff, that would be what I do when I have time left. So like for the first one, state the coordinates of P. I already did that here, so that's fine because that's 5 and 10. Algebra to solve for that. We already discussed about this, that it should be only one answer here. Yeah, because it won't cut up there. So I'm just going to take the left part and less than that. So this seems fine. Let's look at the algebra right here. That seems fine. 4, 5, 4, 2. Yeah, that's fine. C, find the point to which P is mapped. Yeah, by the transformation. So moving right by 2, get 7. Moving up by, sorry, stretching by 3 times. So get 30. So that's right. Okay, yeah, that's fine. Next, write G in the form of that. We just do the long division. So 2x there. And then minus 4x. Subtraction gives me minus x plus 8, pulling it down. And then minus x minus 2 give me 6. And then 6 is the c over that. We are integrating it in b. We get all that. So we get integrate, we get that. That should be all fine. This one, I'm not going to use a calculator because it wants the exact value. So we should rely on our brains. Integrating, blah, blah, blah. 8 to the 2 is 64, 4 to the 2 is 16. This one is minus 8 minus 4 is minus 4. 8 subs here is ln 6. 4 sub here is ln 2. Subtracting gives me ln 3, and all this is just 44. That should be fine, guys. Next one is number 3. Sketch log y against log x, and already did that. There you go. Show on the sketch the coordinates of the points of intersection of the graph with the axes. Already did that. Well, unless I should do that, maybe. And that should also be fine. And then figure 2 show linear relationship. So this is log n against t. So I do y equals mx plus c because y is the log 3n and x is the t. Finding the gradient gives me 2. The c is the y-intercept, which is 4. And then rearranging gives me 3 to the 2t plus 4. And then all of that, I use the laws of indices to rearrange and get me 9 to the t. So that should be fine. This one, harmonic function. Okay, so we do double angle here, get sine 2x. That should be 4 sine 2x, which is this guy. And this is, substituting 4 cos squared x. I move, I multiply out by 2 first, and then I make 4 cos 2x the subject. I get this, I write this. And then minus 3, I didn't forget. And then I got that. That was done. And then I make a harmonic function here. I found r to be 2 root 5 first. That wasn't wrong. And then I expanded the harmonic form to map for the alpha, to find the alpha here. Then I do the arc cos, I get that. And then I updated my solution, writing everything down, not mistaken. And then C, it asks you to find the maximum. So I just take this as a 1, because that's the only way it can get to a maximum. And then my answer is just that. It doesn't ask me to change it to significant figures. So I just do that. And then at this maximum, I found the x. So the second largest, so the second smallest, sorry, positive. So that should be fine, 3 significant figures. I think I make sure that I didn't put non-accurate value in. And then I rearrange, that should be fine. Number 5. This one took a while, didn't it? Yeah, for A, I found the inverse first, and then I substitute 22 in, I get e to the 4, differentiate to prove that g is an increasing function. I did that fine, didn't miss anything. Is increasing because we have a square there at the bottom. The range here of composite function, I do it here. So this is the D part. So we need to find a new domain, and this is already our range. Okay, I'm just going to skip the double checking this one. Okay. This one was a bit fun. So dy dx, I get that 2 over. I am quite okay with this because I got the normal right. So I'm not going to double check much for this. And then algebraic integration to find the area. So let's have a look at the integration. So 3 over 2, 2 over 3, 2 over 3, take 4 out. Hang on. 3 over 2, 2 over 3. 2 over 3, 4 out, yeah. Over 6. And then if I substitute 8 in, I get 25, 25, that. 7 over 4 in, it goes to 0. And then that just 5 because it's half base height. Yep. And then 25 to the power of 3 over 2 is just 5 to the 3, which is 125 plus 5. So I get that. That should be fine. And then the last breath of minutes, I have this question to check, which is also fine, I guess, because I got that. And this one could be a bit tricky, but yeah, we will see. So I get 2 answers to be in the range. Yeah. And then this one, I think it was fine because I can prove that. And then the last minute, I'm just going to go and check this one again, maybe. So I substitute x equals 2 in because that's the value of k. I want to find the normal. So I use that equation there. 2 or 3. I do the normal gradient here. I plug it in the formula. I use x as 2 again and y as pi over 3. And then I just divide that. On the other side, I get this. Then I move 2 to plus. And then I multiply these two terms. I get pi over 6 root 3. And then this will be the base of the triangle, multiplying everything in. That should be fine. I'm done. Time is up. Now, let's stop the time here because it's just up. Now, let's mark the paper, right? Yeah, this is, again, 2024 June. I got the first point there, right, guys? You can see that. Okay. X less than 5 over 2. Got it. 730. That's still fine. So far, so good. I normally mark papers from students. Never mark my paper. Here's the first time, actually. Okay. It was a long time ago when I did A-level. So here we go. What did I do here? Okay. Yeah, I got that. 44, 6 long 3. Voila. Whatever the method, I think I'm right. You can help me check if you want to object to my marking here. Yeah, that seems to be fine. Yeah, that's everything. I derived the log here. And then down here, I got the right value. Okay, here we go. Marking this is easy already, isn't it? Okay, so here's the tricky bit, maybe. Okay, I got that, right? And that is correct. And alpha is that, right? So I updated my solution here, didn't get everything wrong, didn't get anything wrong, I mean, and that is my maximum. And this is 7.3. Ooh, okay. Number 5, so far so good, guys. Number 5, e to the 4, b, what? Oh no, this is not too silly mistake. Why could I have missed that? How could I have missed that? I mean, right. So let's see. Okay, how many marks did I lose? Hang on. So did I lose any marks? Of course, I think so. So A star there means correct, unsimplified, or 10. Yeah, I lose that marks, I think. I lose that mark. I lose the A1 mark, but the final mark, I think I got it. Yeah, I think I got the final mark, guy. I think I got it, guys. So we are not going to deduct my mark away because requires a reason as to why expression always positive. A minimal conclusion. Yeah. Yeah. So I think I got it. So I'm just going to do -1 here. Yeah, this one. Yeah, I'm just doing minus there. And then G inverse is that. Yeah, that's fine. Okay. Yeah, range. I got it up here. 2 plus 5 ln 3. Correct. Good. I'm losing to 1 mark so far. Just one. Just one, guys. Okay. This one should be fine because I get everything right because I can prove the final form for the linear equation here. I shouldn't have the cut there. Why did I? Yeah, whatever. Okay, sorry about that. And yeah, the area is also fine. And then number 7, I have -3 -2 as required, everything required. And then this is right. Excellent. Number 8. Almost the last one now. A. Oops. Oh, no, not oops. That's right. And then B. Yep, I can prove that. And then that one is that one is that. That's all fine. Number 9, the last one. See if I can nail that one. I think I can. Yeah, just substituting get 2 there. dy by the x got that. And then I can prove it's that. So I think I'm right. And then, yeah, this one is right. See that? Yeah, this one might be, woohoo, I got it. So I just lost 1 mark, just under the time of 1 hour, 30 minutes, with also narrating all this to you. So I hope that helps, because I want to do this realistically, because I want you guys to see how I approach all the questions unseen, right? Not having seen it, not having seen them before. So if there's any question you want to ask about this video, you can just comment on the video, and I'll see you in the next video. Thank you for watching.